Good afternoon. I'm Marco Flagg, and this morning I was presenting on a multi-standard deck box that solves one aspect of the ropeless fishing management puzzle, enforcement. Now I'll be talking about a different piece of the puzzle, which is how do you integrate the mobile fleet with the ropeless fixed gear fleet. But in the end, I'll then go on to sort of a big picture for the day for me, which is how do you take these two tools and other tools to have a comprehensive ropeless management regime? At least my thoughts for one. So let's get started. As a mobile gear fisher, how can you know what gear hides under the sea? Well, you have a few options there. You could use a virtual gear marking app where other fishers already indicated where they deployed their gear. You can see it right on the screen from anywhere, from a long distance. It's reliable because everything's already been detected. But there are limitations. These positions are not necessarily up to date. Some gear may just not be marked, or it may have moved. Another option is acoustic or physical gear detection, where you sweep the ground ahead of you with acoustic or sonar signals. There's one such system integrated with an acoustic release that you can sweep from your boat and with a single ping see the whole gear field ahead. There's also more simple solutions like this ping me transponder. Clip it to any gear and it provides you on the boat with location information. And finally, there's very accurate multi-ping acoustic ranging, where positions of gear on the seafloor, such as here, where it drifted from the surface, are determined very precisely by multiple pings from one or many ships in multiple locations. Now, when it comes to integration with the mobile fleet, however, there are challenges. If you want to sweep the seafloor ahead, of course, you need a deck box and a hull or pole-mounted sonar transducer. Acoustic range, how far you can detect, and reliability can be limited by thermoclines and halo clients, like in submarine movies. Seafloor gear may also be shadowed by terrain, and there can be noise issues. And if a single acoustic standard is needed for all gear on the seafloor, that can really limit the choice of fishers, the static gear fishers, who need to put it on each one of their traps and trawls. There can be substantial cost for such systems if they're complex or low frequency. And of course, if you demand such standardization by regulation, you may eliminate low-cost ropeless solutions that some fishers really need. So the question is, isn't there some acoustic gear on fishing vessels already that we could use? And the answer, of course, is yes. It's depth sounders, specifically the low frequencies at or below 50 kilohertz that give you a good range. Now, how might that work? Well, here's a depth sounder display, and you see all these arcs. What are they? They are fish. They are sometimes called fish arcs. Now, why do fish and other small things appear like arcs? Well, it's because when the vessel approaches, the direct or slant range is big. It's interpreted as depth. That's the bottom of the arc. Then we climb up the arc. When we're directly above, the slant range is the same as true depth. And then the arc goes down again. So now, how do we get, though, from fish arcs to active gear arcs, in particular, since these arcs tend to be quite small, so they wouldn't give you much warning? And the solution here is to use an active transponder on your gear that detects and replies to the depth sounder pings. And that will greatly extend your detection range. And then you can also have intermittent replies, like this simulated dashed line here, that makes it distinct from natural reflectors. And you could even code them, say in a Morse code-like fashion, to identify the manufacturer of the particular gear by the first letter of their name. So on first thought, it may appear that this can't really work because, depth sounder transducers are designed with a narrow beam, and so you would just get limited coverage underneath the boat, not enough to really warn you. You'd miss most gear. But when you look at it a bit closer at these beam diagrams, you see that really these depth sounder transducers are quite sensitive in a small beam area, but as you go down to the sensitivity of a typical omnidirectional transducer, such as is used in gear marking, you have a much wider beam. It can capture much more, and you can see that in the manufacturer's published results as well. So we went out for a field test. We deployed a sonar point, that's a broadband acoustic recorder in Monterey Canyon, at a depth of 558 meters. That's about 305 fathoms. Then we just ran a course with a boat while on a fishing boat, while pinging on a 38 kilohertz sounder, and then we recovered the recorder and looked at the results. How strong was our signal based on where the fishing boat was located relative to the mooring on the seafloor. And what we found, not surprisingly, when we were directly above the seafloor mooring, we got a very strong signal. That's no surprise here. But when we then went further afield, here's our scale bar, 1 kilometer, this much, we got still quite a good signal here up to 1.5 kilometer distance. That's about 3 times depth. And then still a weak but usable signal at 2 and 2.5 kilometers. That's up to 5 times the depth at the location. So here you can see that beam pattern again, you know, the advertised beam here, but really we are in the green for much more, and then the yellow, and then even the red. As a skipper, how would you use the information to actually navigate? Well, you would start out with your virtual gear marking app and just plot a course that hopefully avoids most of the gear fields here. Then, of course, you do run your sounder to scan the seafloor ahead of you, and you look for these arcs. Now, remember, if an arc hits the seafloor, that means you're directly on top of the gear, and that's a conflict. So you would want to avoid something like this. But if you see a shallow arc like this, well, the gear is off somewhere to the side, maintain course. If you see this steep arc here, but then it levels off, that means you're just going at a really fast clip, but the gear is still off to the side, so you can maintain course. Let's look at the gear and cost impact for the ropeless fisher. What do they need to get? They need a sounder transponder, and our first version will be to simply implement that in an existing acoustic release by updating the controller board, the acoustic controller, with a software-defined controller that can also detect and respond to sounders at 38 and 50 kilohertz, in addition to doing all the normal acoustic release stuff. So therefore, there's no hardware cost impact, and we expect that the cost of the release will stay the same. Then as the second option, we will develop a standalone depth sounder transponder that can just be clipped to any traps or gear to provide the same functionality. Now, ropeless fishery management obviously has several components. We already discussed today here fishery enforcement in the morning, and now the mobile fishery integration with ropeless. Then there's, of course, ropeless gear conflict avoidance that must be addressed, and how to deal with moved and lost gear recovery. This table is sort of an idea as to how this may all fit together. Essentially, we have multiple tools to address the various objectives of management here. Sounder detection, the multi-standard deck box, virtual gear marking, we use that all today, talked about it, but also some additional stuff I haven't mentioned, public interrogate, and some additional acoustic based correction of virtual gear marks. And the takeaway is really that to manage all this, what we can do is we can use not just one tool, but a combination of overlaying or sequence tools to address the various objectives of management, and thereby perhaps arrive at a comprehensive management plan. There's a saying that technology always starts out as sci-fi, impossible, then it becomes possible but complicated, and finally it becomes simple. And I think that's where we really all want to go in ropeless, is technology that is simple for us, that is affordable, practical, redundant, robust, That's what we're looking for. And I hope we can come to the point where sometime in the future we might, for example, see a nautical chart that, as I indicated here or notice to Mariner, saying something like this: caution, submerged gear may be present, check your 38 kilohertz or 50 kilohertz sounder. Simple stuff that we can follow, that we can be happy with. Thank you very much.